In this video, I would like to talk about tuning the kernel using the Sysctl command. So tuning the kernel is basically modifying the parameter of the kernel so that our system can be better optimized or either work with better stability and other resources can be well used on the system depending of what result we are trying to have. So if we like to see all the different parameters that we can tune on our kernel, we need to do a Sysctl-A. It's giving us a lot of value, and if we pipe that into a word count, we see that we have about in this machine 1032 different value that we can tune on this machine. In this video, we're going to take 2 or 3 different examples of tuning that we can do so that we can better understand this concept. So in one of our previous video, we talked about swap partition. So while creating the swap partition, if I do here a free-m, we see that we have a normal memory and we have a swap here that is supposed to behave as a memory. The question is, how does our system will know that it needs to start using the value of swap that we have set? And for that, the kernel will be looking at the parameter that is being set. If we do a Sysctl-A R for regular expression on swap, here we see that our swappiness is set to 30, which means when we're going to use 70% of the value of our memory, as the moment that we use the 70%, we need to start, our system needs to start using the value of swap that we have set. So for the system to know that it needs to start using the swap, it needs to see if there's any resources or the resources of the memory is being used to up to 70%. Since here we have 30, meaning it will be used to up to 70% before a swap need to take in effect. So if we want to change that value of swappiness, we need to use the command Sysctl -w into Sysctl-w, and we need to specify the value of our swappiness here. And we need to remove the space here. And it said that our value of swappiness will be switched to 20% in this case. And if we recall our command, in this case, when we're going to utilize our memory to up to 80%, now the value of swap need to take effect. Setting the value of swappiness using this command is going to set it up temporarily. I mean, if we reboot our system, is going to go back to the value of swappiness of 30. If you want to make it permanent and persistent at reboot, we need to vi in a file etc sysctl.d and d, and here we're going to create a file called swap.conf. The name of the file here does not really matter. What is most important is the value of .conf. That's how our system will know that it's a configuration file that we are trying to set there. So I will copy this value so that I will make sure that I don't make any mistake while typing, and I'm going to paste that. And for example, if we would like to change it to 10, and to notify our system that we have made a change, we use the command Sysctl-p on /etc Sysctl-p on swappiness. So the value is being prompted here to us, and that's how we know that we have set our swappiness to 10, mean when our regular memory will be used up to 70, 90%, the swappiness are going to take effect in this matter. Another situation that we can use to twin our kernel is to make our machine behave as a router, which is usually called as a IP or forwarding. And to see what is the value of the IP forwarding now, we need to do a Sysctl -AR, and we look for a value of forward. And this is what we are looking here. So this value is being set to 0 mean our system is not behaving as a router at the moment. And if you like to change that to make it behave as a router, we can do it temporarily in the first place by doing a Sysctl -W, and we enter that value here, and we need to switch that to equal 1. Now it said that our forward is set to 1 here, but this is temporary. If we want to make it permanent, so it's going to be persistent at reboot, we BI in a file called etc sysctl.d, and we want to call it forward. And again, the most important is to add the .conf on this file so that our system will know that this is a configuration that if we need to read. And in here, we're going to enter the value and change it from 0 to 1. And we do a Sysctl -p to notify the change that has been made on the system right now and forward. So that's how we can decide to make our system to start behave as a router, which is something that we use a lot on clustering, when we're trying to make multiple devices communicate through the network with each other. The third example that we're going to use here is going to be about the case of the ICMP. Sometime when we ping a device to see if a device is available, our kernel is responding to let us know that yes, that device is actually available by, sending a message back from the ping that we get. So we can decide to block it by saying to our kernel, when somebody pings you, do not respond. And to do that, we tweak our kernel. We need to look for the value of AR here. Let's look for ICMP. And we need to switch this value from 0 to 1. When it's set to 0, that's when the kernel will respond to anybody who's pinging it. But let's decide to change it to Sysctl we're going to call it ICMP.conf, and we're going to add that value and switch it to 1 for this method. So we need to notify the change that have happened by doing a Sysctl -p into that value. So at this point, if we try to ping that device again, we are not going to get no feedback because we have tuned our kernel so that it will not reply to anybody who is trying to have access, who is trying to see if our server is alive. So if we decide to go and change that value back to 0 again, which is allowing the response from our kernel, And we will see that as soon as that value is changed to 0, now our system start allowing the pinging again. So these are the couple examples on how to tune the kernel using the sysctl command, and modifying all the different parameters so that we can have our system behave the way we will desire. So you guys have fun and enjoy Linux.